Welcome students, welcome to IC Engineering class. Today we are going to learn about ignition system, basically battery ignition systems and magneto ignition system. You have already learned what is ignition system and the basic knowledge of the ignitions. You already learn about that. So let's start. As an air is a poor conductor of electricity, an air gap is an electrical circuit act as a high resistance. Okay, so but when the high voltage is supplied across the electrodes of a spark plug, it produces a spark across the gap. So when such a spark is produced to ignite a homogeneous air fuel mixture in the combustion chamber of an engine is called a spark ignition engine. Okay, so the ignition system is classified into two types. First one is the battery ignition system and second one is the magneto ignition system. Okay, so let's start from the battery ignition system. As you can see, this is a block diagram of battery ignition system. So in the most modern spark ignition engines use the battery ignition system. In this system, the energy is required for producing the spark is obtained from a 6 or 12 volt battery. The construction of a battery ignition system is extremely varied. It depends on the various type ignition energy stored as well as on the ignition performance which is required by the particular engine. The reason for this is that an ignition system is not an autonomous machine, that is, it does not operate completely by itself. So by instead it is but one part of the internal combustion engine. Okay, so it's one part of the combustion engine. Okay, that means the heart of the engine. So it therefore extremely important that the ignition system must be matched sufficiently well to this engine. Okay, the passengers car, light trucks, some motorcycle and large stationary engines are fitted with battery ignition system. The details of the battery ignition system is shown in this figure. Okay, first one is the battery. This is the battery. Okay, this is the battery. Second is ignition switch. This is the ignition switch. Okay, third one is the ballast resistors. This is the ballast resistors. Then the ignition coil. This is the ignition coil, primary and secondary, the both side. Contact breaker. This is a contact breaker. Capacitor. This one is the capacitor. Distributor. This is the distributor. Okay, and last one is the spark plug. These are the spark plug. 1 2 3 4. Number one is the spark plug for first cylinder number 1. This one is the spark plug for cylinder number 2. This one is the spark plug for cylinder number 3, and this one is the spark plug for cylinder number 4. So now the operating or the working principle of the battery ignition system. So let's start. The source of the ignition energy in the battery ignition system is the ignition coil. Okay, so this coil stores the energy in its magnetic field and delivers it at the instant of ignition, that means at the instant of firing, in the form of a surge of high voltage current or the ignition pulse through the high tension ignition cables to the correct spark plug. Okay, so storage of energy in the magnetic field is based on an inductive process, as a result of which we also designate an ignition coil as an inductive storage device. Okay, so as shown in this schematic diagram, as I have already explained that the ignition coil consists of two coils of wire, one wound around the other, the insulated from each other. The primary winding, suppose this is a primary winding, suppose this is L1 with a few turns of heavy copper wire, and the secondary winding, this one, is L2 with many of fine copper wires. Okay, many turns of fine copper wires. The primary and secondary windings are wound around the limited iron core. This one is the iron core. Okay, which has the effect of increasing the strength of the magnetic field and thus the amount of energy stored. Okay, so one end of the primary winding is conducted through a ignition switch, this one, to positive terminal of the post of the storage battery. It is a positive terminal as shown in this figure, and the other end is grounded through the contact breaker. This one is grounded. Sorry, this one is the grounded through contact breaker. This is a contact breaker. Okay, the ignition capacitor is connected in parallel with the contact breaker. These two are the parallel connection, and the one end of the secondary winding is also grounded through the contact breaker, this one, and the other end connected through the distributor and the high tension ignition cable to the center electrode of the spark plug. That means this is the cam is connected with the cam, and this line is connected with the ignition distributor. Okay, so when the ignition switch is closed, the primary winding of the coil is connected to the positive terminal post of the storage battery. If the primary circuit is closed through the breaker contract, a current flows. The so-called is called primary current. Okay, if the primary circuit is closed through the contact breaker contract, a current flows. That is called the primary current, and this current flows through the primary coil, which wound a soft iron core produces a magnetic field in the core, and a cam driven by the engine shaft is arranged to open the breaker point whenever the ignition discharge is required. When the breaker point opens, the current which had been flowing through the point now flows into the condenser, and which connected connected across the point. The condenser becomes charged and the primary current falls, and the magnetic field collapse. Okay, the collapse of magnetic field induces a voltage in the primary winding. Such current the condenser to a voltage much higher than the battery's voltage. The condenser then discharges into the battery and reversing the direction of both primary current and the magnetic field. The rapid collapse of and the reversal of the magnetic field in the core induced a very high voltage in the secondary winding of the ignition coil. The secondary winding consists of a large number of turns of very fine wire wound on the same core with the primary. The high secondary voltage is lead to the proper spark plug by means of rotating switch called the distributor. This is the rotating switch. Okay, this is the distributor, which located in the secondary or the high tension circuit of the ignition system. A condenser were not used in primary circuit. The high primary voltage caused the collapse of the magnetic field around the primary winding would cause an arc across the breaker points. The arc would burn and destroy the points and would also prevent the rapid drop in primary current and the magnetic field, which is necessary for the production of the high secondary voltage. So we have to remind that the spark timing is controlled by the crank angle at which the breaker points open, while the distributor merely determines the firing sequence of the spark plug. The changes in the ignition timing may be affected by the rotating the plates which holds the breaker points relatively to the cam. Because of this, ignition will delay the delayed if the plate is displaced in the direction in which the camshaft rotates. Okay, so this is the working principle of the battery ignition system. Now the magneto ignition system. So a magneto is a special type of ignition system with its own electric generator to provide the necessary energy for the system. It is mounted on the engine and replace all the components of a coil ignition system except the spark plug. A magneto, when rotated by an engine, is capable of producing a very high voltage and does not need a battery as a source of external energy. A schematic diagram of a high tension magneto ignition system is shown in this board. Okay, so the high tension magneto incorporates the winding to generate the primary voltage as well as to step up the voltage, and does not require a separate coil to boost up the voltage required to operate the spark plug. A magneto can be either rotating armature type or rotating magnet type. In the first type, the armature consists of the primary and secondary winding all rotate between the poles of secondary magnet. While in the second type of the magnet involves the winding are kept stationary. A third type of magneting is called the polar inductor type and also in use. In the polar inductor type magneto, both the magnet and windings remain stationary, but the voltage is generated by reversing the flux field with the help of soft iron polar projections called inductors. Okay, so the working principle of the magneto ignition system is extremely exactly the same as of the coil ignition system. With the help of a cam, the primary circuit flux is changed and the high voltage is produced in the secondary circuit. In comparison, the battery ignition system is more expensive but highly reliable. But because of the poor starting characteristics of the magneto system, is invariably the battery ignition system is preferred to the magneto system in automobile engines. Wherever in two-wheelers, the magneto ignition system is favored due to the lightweight and less maintenance. The main disadvantage of the high tension magneto ignition system lies in the fact that the wirings carry a high voltage and thus there is a strong possibility of causing engine misfire due to leakage. To avoid this, the high tension wire must be suitably shielded. The development of the low tension magneto system is an attempt to avoid the trouble. In the low tension magneto system, the secondary windings is changed to a limited to secondary voltage to the value of 400 volts. Okay, and the distributor is replaced by a brush contact. The high voltage is obtained with the help of step up transformer, and these changes have a effect of limit the high voltage current in a small portion of the ignition system wiring, and thus avoid the possibility of leakage. Okay, so this is the magneto ignition system. The working principle is quite as I have described, the same as the battery ignition system. So thank you.